Hi everyone, let's start section 3 of lecture 2 or chapter 5 of our textbook. As I said, we are still in chapter 5 inventory control with uncertain demand. So we are going to have the remaining uncertain models of inventory control in chapter 5 in this section, section 3, and the last section of lecture 2. Okay. This is our agenda for this section or this week. We will have the service levels in QR systems. So this is a new concept you are going to learn in this section, and an alternative approach to obtain the optimal levels for Q and R. And then we'll have the imputed shortage cost, scaling, lead time demand, lead time variability. Here we consider that lead time is a random variable as well, and see how we can deal with this uncertainty. And then we'll have S policies in inventory control, and then the complexity of inventory control in the real world, and also ABC analysis for more complex inventory control models in the real world. Okay. In the QR model that we had in section 2 previous week, if you remember, we had the penalty cost, right? We considered a penalty cost P for each unit short during the lead time, right? So yeah, by having that penalty cost, we could formulate the problem, and then we could obtain the optimal level for Q and R, or their quantity and a reorder point, right? So what if we are not able to estimate the penalty cost? Yeah, there are many circumstances in the real world that we can't estimate the penalty cost. So what should we do in that case? In that case, we can apply an alternative approach, which is called service level approach. So here we have two types of service levels, type 1 and type 2. In type 1, it's defined based on a probability of not stocking out in the lead time. So yeah, in type 1, we are going to consider a percentage of time that we are not in the stock out situation. But in type 2 service level, we're going to consider the proportion of demand that is met from stock. Okay, so let's see how these two are different and how they can be applied in the QR model to obtain the optimal level for Q and R. Okay. Let's have the type 1 service level, or alpha, first. So in this service level, we would like to have no stock out situation at alpha percent of daily time. So yeah, as we see here, we are going to set a criteria for our company in order to have a service level that, let's say, for example, at more than 95% of times during the lead time, we are not in the stock out situation. Or we can say we may be in a stock out situation at most in 5% of times. So that will be our service level. So here we say that our service level is 95%. So that 95% here is considered as alpha. So we are going to consider this situation that in alpha percent of times during the lead time, the system is not in the stock out situation. Okay, so we can obtain then reorder point by this. So yeah, I mean, having no stock out situation alpha percent of time during the lead time means that the probability of demand be less than or equal to the reorder point should be equal to alpha, right? If r equal to alpha. So by this equation, we can obtain the reorder point. So here is the optimal solution. The reorder point r will be obtained by this equation if r equals the alpha. So alpha is the given parameter, right? It comes from the company's objectives, right? Yeah, company said that strategy or its policy in order to have alpha as its service level. So we consider that as a given parameter here, and then by having that we obtain R, reorder point. And the order quantity, optimal order quantity here will be just the EOQ, right? Yeah, as since we don't have the penalty cost here, so we can't go with that equation that we had in section 2 in QR system for Q. Here we ignore that and we just consider the EOQ, the simple EOQ model for Q, and R will be obtained by this equation if R equals to alpha. Okay, so as you see here, we are considering this service level uh, if the consequence of having shortage is the same for any amount of shortages. I mean the consequence of being stuck in a stuck out situation is independent from its occurrence time and also the amount. So no matter how many items are shorts, if we are in a stuck out situation, it has the same consequences to that company. So, for example, a production line is stopped regardless if there is 1 unit short or 100 units short. So as you see here, the cost of shutting down the production line is the same if we have just 1 unit short or 100 units short. So as you see here, we can apply this approach in the cases that it doesn't matter how many items we are short. The only thing that matters here is being in stock out situation, and that's it. Okay, and the type 1 service level also called lead time service level. Okay, type 2 service level or beta. Here we define the service level as this: the proportion of demand that is met from stock, and we show this proportion by beta. Okay, so yeah, here we are going to take into account the amount of the shortage units. So we care about the items short, the numbers, the quantity. So it's not just a matter of being in a stock situation. Also, the volume and the quantity of units short is important here. Okay, so as you remember, NR divided by Q is a fraction of demand not satisfying from the stock, right? So in that case, NR over Q will be 1 minus beta, because beta is the fraction of demands are going to be satisfied from the stock. So 1 minus beta will be the fraction of demands that are not going to be satisfied from the stock. Okay, and so here the EOQ actually is not optimal for this approach, but we consider EOQ here. So it will be a very good approximation, and it will give us very good results. So yeah, we obtain the EOQ for the order quantity, and R will be obtained by this equation: NR over EOQ. Here Q is EOQ, right? Equals 1 minus beta. So by this equation we can obtain the reorder point. So as you see here, the calculations of service type 1 service level is much easier than service 2, right? But since this case, I mean, a type 2 service level considers the amount of shortage, it's more accepted in this industry. So onto this service level is called fill rate. So the fill rate of demand from the stock. Okay. So in order to compare the two service levels, let's have an example here. Let's assume that we have this historical data for the past 10 order cycles, and as you see here, in 2 cycles we were in a stock out situation. See? Yeah, in cycle number 3 and number 6, we were in a stock out situation, and the units short in order cycle 3 was 45, and in 6 was 10. Okay, so if you want to calculate type 1 service level, I mean the percentages that we were in a stock out situations, as you see here, in 2 cycles out of 10 we were in a stock out situation. So we can say the probability of being in a stock out situation is the probability of not being in a stock situation is 8 over 10, right? So it will be 80%. So here the service level type 1 is 80%. This means that in 80% we were not in stock out situation, but in 20% we were in stock out situations, right? But for type 2 service level here, as you see here, the total demand during the past 10 cycles was 1450 items, and the units shorts, the total is 55. So 55 divided by 1450 is the fraction that we had a shortage, or we can say the fail rate here, or the beta service type 2 service level is 96.2%. This means that 96.2% of the demand has been satisfied from stock, and so this shows our fail rate or type 2 service level. So as you see here, these two service levels are completely different and have different, influence in the company's policies and strategies. Okay. So let's have an example here. Example 5.5 of our textbook. So we had this example in the previous section, and I solved this example in the live session previous week. So if we recall those numbers, we obtained 110 for Q and 143 for the reorder point. So now let's see, by having this decision, what will be our service level in terms of type 1 and type 2. Okay, so for type 1, FR equals alpha, right? So in order to obtain the alpha, we just need to obtain FR. And if you remember, we had this equation for that example, 1 minus FR equals Q times H over P times lambda, and this was 0.04, right? So by having this FR equals alpha here, it becomes 0.96. So this means that our type 1 service level is 0.96, or in 96% of times we will not be in a stock out situation, and we may be in a stock out situation in 4% of times. Okay, and what about type 2? Type 2 here, we have this equation 1 minus beta equals NR over Q, right? So beta here becomes this. Let me, okay. So 1 minus NR over Q. So if you remember, NR was this number for that example, 0.405 divided by 110, and this becomes 0.996. What a great number. So as you see here, this is our beta or fail rate. Okay, and this is our type 2 service level. So now let's try other service levels. So as you see, the current service level for type 1 is 96%. So and we want to see what if we want to increase this type 1 service level from 96% to 98%, and then what should be the reorder point then. Okay, so in order to solve this when we solve for this service level here, here we say that if R should be equal to 0.98, right? So if we go to table A4 and obtain the Z of 0.98, it will be 2.05. Okay, and here we know that Z equals R minus mu over sigma. Then R will be equal to mu plus Z times sigma, right? Z of alpha. Okay, so R then becomes 100 plus 2.05 times 25, right? Yeah, 25. And by having that, R becomes 151. So this means that if we want to increase our type 1 service level from 96% to 98%, then we have to increase the reorder point from 143 to 151. Okay. And now let's say that 0.996 for the fill rate is too much for us, and we can decrease it to 0.98. Then let's see what will be our reorder point then. So here we know that the LZ equals NR divided by sigma, right? You remember this equation from the previous section. So here, the NR in this, when we have type 2 service level, equals EOQ times 1 minus beta, right? And so divided by sigma. Okay, so here the EOQ, so here that's the point. Here we are not going to consider the Q. Here we need to consider the EOQ for type 2 service level, and the EOQ for this example is 100, so times 1 minus beta, which is 0.02, divided by the sigma, which is 25. Then LZ here becomes 0.08. Okay, 0.08. Then if you go to table A.4, this table A.4, then by having the LZ of 0.08, then Z is obtained as 1.02. Okay, now we do have Z and we want to obtain R, so as you know, R equals mu plus Z times sigma, right? Now R will be again 100 plus 1.02 times 25, and it will be 126. So yeah, as you see here, if the fill rate of 0.996 is too much for us and we want to decrease this to 0.98, then we need to decrease the reorder point from 143 to 126. Okay, and that's it for the first part of this section. So we'll have more models of uncertain inventory models in the next parts. Okay, thank you.